How dark energy determines the fate of the universe. We've already made a video about the mysterious dark matter, in which we explained that only a small part of the universe consists of ordinary baryonic matter. In this video, we'll take a closer look at the no less mysterious dark energy. But one thing should be said in advance: it's one of the greatest unsolved mysteries of cosmology. The term dark energy was coined in 1998 by Michael S. Turner, a theoretical astrophysicist at the University of Chicago, and so far we don't know very much about it. We assume that dark energy is an unknown form of energy that affects the universe on the largest scale. Throughout the European Planck mission, we know that it makes up 68.3% of the universe. The first observational evidence for its existence came from measurements of supernovae, which showed that the universe's expansion is accelerating. This discovery was awarded the Nobel Prize in Physics in 2011. This has far-reaching consequences. While until a few years ago it was still discussed whether there could be a big crunch, that the universe would contract again due to the gravitational force, today a big freeze is more likely. This means that should the universe continue to expand, it will eventually become cold and dark. Even more strangely, the expansion has been decelerating until 7 or 8 billion years after the Big Bang, as observations by the Hubble Space Telescope of very distant supernovae have shown. For a universe that began with the Big Bang, this is a remarkable fact. But then, for reasons completely unknown, a mysterious anti-gravity force started to dominate, overcoming the brake that gravity was placing on the expansion, which then reversed its slowdown and started to accelerate. To add to the mystery, the properties of this strange dark energy seem to match Einstein's cosmological constant, usually symbolized by the Greek letter lambda, and later described by Einstein himself as the greatest professional blunder of his life, because Einstein favored a statical universe. So far, no one knows what's behind this phenomenon. Maybe Einstein was right with his cosmological constant, and dark energy really is a kind of vacuum energy of empty space. Other researchers suggest that maybe there is some strange energy fluid that fills space, a fluid where the energy density equals the negative pressure. Some theorists have named this Quintessence, after the fifth element of the Greek philosophers. Or perhaps something is wrong with Einstein's theory of gravity, and a new theory could include some kind of field that creates this cosmic acceleration. There are several current and future space missions and ground-based surveys which will investigate the nature of dark energy, including NASA's orbiting WFRIST telescope and the International Dark Energy Survey based in Chile. Maybe one day we'll find an answer. Thank you for your attention.